Problem number 25. A force F vector which is equal to 6 Newton I cap minus 4 Newton J cap acts on a particle with position vector R which is equal to minus 3 meter I cap plus 1 meter J cap. And we have two questions here. First question, we have to find the torque about the origin acting on a particle. In the second question, we have to find what is the angle between R vector and F vector. So here we have two vector equation. One is for force, one is for position vector. Let's write that first. So force vector F vector which is equal to 6 Newton I cap minus 4 Newton J cap. And then the position vector R vector which is equal to minus 3 meter I cap plus 1 meter J cap. And by using these two vector equation, first we have to find the torque. So that means the first part we have to find the answer for the torque. Tau. We have to find the torque tau. And second part we have to find the angle theta between R vector and F vector. So we have to find these two answers. So first of all, let's we just go back to our theory. So what formula we studied for torque? Torque tau which is equal to R cross F. This formula we studied. So here we have to use this formula for finding the answer for the torque. Why? Because here we have the force in terms of vector form, and then the position vector R is also in the vector form. So we have to use, because we can, if you rearrange this equation, which is nothing but RF sine theta, but I am not going to use that RF sine theta here. Why? Because here the force vector and the R vector is given directly, so we can deal with the cross product. So why? If you want to find the answer by using the cross product, then we have to go back to the IJK rule, what we studied from chapter number 3, vector. Clear? So now I'm going to use by using the IJK form. So let's we apply the rule first. R vector, that is torque tau, which is equal to R cross F, which is equal to the matrix form. So I can write I cap, J cap, and K cap. So now I have to write the IJK value for the R vector. So here I cap value is minus 3, and then J cap value is 1 meter, and then there is no K cap. So what we have to do? We have to put 0. Likewise, I have to write the force vector. So let's we just see what is our force vector. The I component of the force vector is 6 Newton, and then the J cap value is minus 4, and then there is no K cap. So what we have to do? We have to put 0. Now we have to do the method. So what we studied, I takes the value of positive, J takes the value of negative, and K takes the value of positive, right? So first we start with I cap. I is positive value of I, so I can write I cap. And then when you deal about this I cap, what we studied, we should not touch the first row and the first column. We have to multiply this here. So if you multiply this one in this direction, and then minus of this multiplication. So 0 multiplied by 1 is 0. Minus of minus 4 multiplied by 0 is 0. So this term becomes 0, right? And now what we have to do? We have to come for J cap. And the J takes the value of minus, right? So I have to write minus J cap. So in this time, now what we have to do? We should not touch the first row as well as the middle column. That means first row and second column we should not touch, only we have to multiply. So better I can first explain this part. Now you can see for J cap we should not touch the first row and then second column, and then we have to multiply. So for J cap what you will get? 0 multiplied by minus 3 is 0, and then minus of 6 multiplied by 0 is 0. So for j cap, again the value 0. Now for k cap, what we have to do, we should not touch the first row and the last column. Now we have to take the value here. So minus 4 multiplied by minus 3 is plus 12, minus of 6 multiplied by 1. So here I can write the value. When we take the I cap, what we got? Because for I cap, 0, 0 minus 0 we got. Likewise for j cap also, it's 0 minus 0. But for k cap, it takes the value of plus. So k cap, now you can see minus 4 multiplied by minus 3 is 12. Minus of 6 multiplied by 1 is 6. So here I and j, there is no value because anything multiplied by 0 is 0. Only we have the value for k cap. So the answer for the torque tau, which is equal to 12 minus 6 is 6 Newton meter, and then which is for k cap. So this is the answer for the first part. And for second part, we have to find the angle. We have to find the angle theta. So for that, what we have to do, we have to use the dot product formula. What is the formula for dot product? Go back to chapter number 3. We studied the rule A vector dot B vector, which is equal to magnitude of A vector, magnitude of B vector multiplied by cosine of theta. So if you have any questions regarding finding the angle between two vectors, you have to find the angle only by using the dot product. So here we have two vectors, which is r vector and f vector. So I can apply the rule based on the dot product of A dot B. So r vector dot f vector, because the torque formula is rf, right? So r vector dot f vector, which is equal to magnitude of r vector multiplied by magnitude of f vector multiplied by cosine theta. So I have to use this rule for finding the answer for angle theta. So let's rewrite this formula one more time. So r vector dot f vector, which is equal to magnitude of r vector multiplied by magnitude of f vector multiplied by cosine theta. First, let's rearrange this equation in terms of theta. So first of all, I'm going to keep the cosine theta here. I'm going to move this magnitude of r and magnitude of f to the left hand side of the denominator. By that, we will get the equation cosine theta, which is equal to r vector dot f vector divided by magnitude of r multiplied by magnitude of f. Now for getting the answer for theta, we have to move the cosine to the right hand side. By that, the cosine will take the negative value. So theta, which is equal to cosine inverse of r vector dot f vector divided by magnitude of r vector multiplied by magnitude of f vector. That's it. Now let's see the value for r dot f. So better I can write the vector form of this r and force, the f vector. R vector value is, we can go back to the question to see what is the equation for r and f. So r takes the value of 6 Newton I cap minus 4 Newton j cap, and sorry, f vector is 6 Newton I cap minus 4 Newton j cap, and r vector is minus 3 meter I cap plus 1 meter j cap. Better I can write this one here. By that, we can easily find the answer for r dot f. So first I'm going to write the r vector. What's the value? Minus 3 meter I cap plus 1 meter j cap, and then f vector value is 6 Newton I cap minus 4 Newton j cap. Now I'm going to find the r dot f. So what is the value for r dot f? What we studied in chapter number 3, you have to multiply only I with I and j with j. So what we will get for this, 6 multiplied by minus 3 is minus 18, and then I dot I, which is nothing but 1, right? Likewise, you have to do the same thing, plus minus 4 into plus 1, which is nothing but minus 4, and likewise j dot j is nothing but 1. So here minus 18 we got, minus 4 we got. So minus 18 minus 4 we got minus 22. So which is nothing but r vector dot f vector, and the unit is nothing but Newton meter. And likewise, we have to find the magnitude value of r. So for finding the magnitude value of the r, what we have to do, we have to take the I component square plus j component square. So let's we take the r vector. What is the value of I cap value, which is, that is x component and y component. So x component value is -3. So -3 square plus 1 square, which is nothing but -3 square is nothing but +9 plus 1. So we got √10, which is equal to 3.16, I think so. So better I can check one more time. So √10, yes, 3.16 I got. So √10 is nothing but 3.16. Unit is meter. Likewise, I have to find the magnitude of the f vector. So magnitude of f vector, which is x component square plus y component square. What is our x component? 6 square plus minus of 4 square. 6 square plus minus of 4 square. So 6 square is nothing but 36, and minus 4 is nothing but plus 16. So here we got 36, 40, 52. So root of 52 we got. Let's see what is the answer for that. So root of 52, I got 7.21. So the answer here is 7.21 Newton. Now I'm going to substitute all this value in this formula. So let's we substitute one by one. So theta, which is equal to cosine inverse of, what is the value of r dot f? We got -22. And then what's the value of r vector magnitude, which is 3.16. And then f vector magnitude, we got 7.21. 7.21. So let's see what is the answer. Cosine inverse of -22 divided by 3.16 multiply with 7.21. Here I got the answer as 164.92. So theta here is 164.92 degree. So if you just rounded this, we can write the theta as 165 degree. So this is the answer for part B. That's it. Thank you.